My name is Bhupinder. Today we would like to talk about the Unit 2 chapter Mechanism of Organic Reaction. Introduction. Reaction is said to occur when the reactants get converted into products, or reaction is said to occur when old bonds break and new bonds form. The breakage of old bonds and formation of new bonds involve redistribution of electrons. The nature of the reaction may be simple or complex. The simple reactions take place in the one step, while complex reactions take place in more than one step. The step through which a complex reaction takes place is called the mechanism of reaction. Arrow notations. The arrow in the chemistry shows the impression in different ways. The same arrow under different condition may give different sense. Organic reaction thus involve the breaking and making of covalent bonds. The covalent bond is generally represented by the dash. The movement of the pair of electrons is shown by a curved arrow. The tail of the curved arrow indicates the atom from where an electron pair moves from, and the heads of the arrow indicates the atom where its move to. The movement of a single electron is shown by a fish hook arrow, half-headed arrow. The different arrows shine in different ways as given under. Let's talk about the bond fusion. Bond fusion, the process of breaking of the bond is called bond fusion. The bond fusion can take place in different ways. Type of bond fusion. Organic reaction involves making and breaking of covalent bonds, and the bonds between atoms are broken in two ways. A. Homolytic fusion, homolysis, and B. Heterolytic fusion, heterolysis. Let's talk about the homolytic fusion. Homolytic fusion, a covalent bond is formed by sharing of an electron pair between the two atoms. Homolytic fusion of the bond causes separation of each electron. Such a process is indicated a fish hook arrow, which denotes a single electron displacement. The neutral chemical thus obtained have odd electron are called the free radical. Homolytic fusion are usually carried out at high temperature and under influence of your under ultraviolet radiations, or in the presence of radical indicators such as peroxide, tetramethyl lead, etc. Then we will talk about the heterolytic fusion. In this type of fusion, the shared pair of electron is retained by the more electronegative atom of the bond. This is indicated by a curved arrow which denotes a two electron displacement. Heterolytic bond fusion requires greater energy than homolytic bond fusion. The energy required to cause heterolytic bond fusion is obtained by dipole-dipole interaction. Since heterolytic fusion results in the formation of ions, it has also known as the ionic fusion. The example given below, the carbocations and carbon ions. Let's talk about the difference between the homolytic bond fusion and heterolytic bond fusion. Homolytic bond fusion, the process in which each of the atom takes away their own electron, is called homolytic fusion, and the process in which one of the atom takes away the both electron is called heterolytic bond fusion. Second, the homolytic bond fusion takes place when both of atoms are of same electron, but in the heterolytic bond fusion take place when the both of the atom are the different electron negativity. Third, the homolytic fusion generally takes place in the presence of the light, and the heterolytic fusion generally takes place in the presence of heating. Homolytic bond fusion. During the homolytic bond fusion, odd electron species, free radicals, triplet carbines are formed. But in the heterolytic bond fusion, cations and anions, singlet carbon, benzene are formed. Then talking about the ions are the positively or negatively charged species are called ions. Types of ions. The ions are of two types. Cation. First of all, cation. The positively charged species also called cations. If the positive charge is present on the carbon cation, then the species is called carbonium ion, and the carbocation, the bond angle is 120 degree in the carbonium. And in the second, anions, the negatively charged species is called anions. If the negative charge is present on the carbon atom, then the species are called carbon ion. The types of reagent. We know that in a chemical reaction, the starting material called reactants react together to form the product. The reactants are further classified as the reagent and substrate. Actually, there is no clear-cut distinction between these two terms. In generally, a more reactive reactants is called the reagent, and the less reactive reactants is called the substrate. Example of benzene as a substrate plus nitronium ion as a reagent gives us Armenium ion and nitrobenzene. In the above reaction, benzene is the substrate and the nitronium ion is the reagent. Let's talk about the types of reagent. The ionic compound has the two parts. The firstly positive part is electrophile and secondly with some exception. Example, in HCl, first positive part H plus ions in electrophile and second negative part Cl negative is nucleophile. Then the reagent are broadly classified into two types. First of all, nucleo reagent or nucleophiles, or we're talking about the electrophilic reagent or electrophiles. Let's talk about the nucleophilic or nucleus loving reagent or the nucleophiles. Let's see. These are electron-rich chemical species containing an atom or group having least a lone pair of electrons that can be donated to the electron-deficient atom or species. Hence, all the nucleophiles and the Lewis base also they attack a site of low electron density. These are two types. First of all, negative nucleophiles. This species contain an atom having the unshared pair of electron and are also negatively charged, for example Cn, Or, OHI and Br, etc. And about the neutral nucleophiles, these contain an atom having unshared pair of electron but carry number of charge, for example NS3, H2O. These are the example of neutral nucleophiles. Further talking about the electrophilic or you can say electron loving reagents or electrophiles, these are the species with which contain an electron deficient atom in its electrophiles are in search of electron and thus combined with the electron rich species. These are the Lewis acid also. They attack the site of the substrate where the electron density is high. Electrophiles are of two types, positive electrophiles and neutral electrophiles. Let's first talk about the positive electrophiles. These species contain an atom or a group which is electron deficient and carries a positive charge, for example hydrazonium ion and the nitrosonium ion and nitrosonium ion. These are the types of positive electrophile. Neutral electrophiles, these are the neutral species having an electron deficient atom. In such cases, electron deficient atom usually has an incomplete octet or vacant d orbital in it. For example, AlC3, FeCl3, BF3, carbenes, SnCl4, molecules which contain polar multiple bond can also act as an electrophile. Further moving on, let's talk about the difference between electrophiles and nucleophiles. First of all, in nucleophiles, the species which have affinity for the positive charge are called nucleophiles, whereas the species which have the affinity of the negative charge are called electrophiles. Types of nucleophiles we have done and the types of electrophile we have discussed further. In the charged nucleophiles, the species which have lone pair electron along with the presence of negative charge on the neutral atom called the charged nucleophile. Example OH हो गया, Cl नेगेटिव हो गया, एक्सेट्रा. और बात करते हैं चार्ज इलेक्ट्रोफाइल्स के बारे में. द स्पीसीज which contain vacant orbital along the presence of positive charge on the central atom called charged electrophiles. Example H positive, NH positive, H3O positive, etc. Okay. Then we move forward about the reaction intermediates. Okay, most of the organic reaction occur through the participation of certain chemical species which are generally short-lived and high reactive. Their involvement can only be detected either by the spectroscopic method or by the trapping them with a more reactive substance. The short-lived, that low half-life reactive species which are formed during the reaction by homolytic or heterolytic fission called the reaction intermediates. Example, carbonium ion हो गया, carbanium free radical, carbines, nitrines, arenes are the example of reaction intermediates. Okay, carbanium ion. The positive charge trivalent short-lived that low half-life reactive species which are formed during the reaction of heterolytic fission is called carbonium. Example, let's talk about the methyl cation CH3, trimethyl carbonium ion, or the tubutyl cation, or benzyl cation, or alkyl cation are the example of such carbonium ions. Okay, moving further, nomenclature are the two types of nomenclature. Carbonium ions nomenclature, formerly these species are called as the carbonium ion, but it is the inappropriate because onium means covalency higher than that of the neutral atom. Therefore, term carbonium ion was used to name ions such as CH5 positive or methananium ion, nor boronyl cation. This is important to understand about the carbonium nomenclature. Let's see. So this type of nomenclature is given to the non-classical carbon cation, also called bridged carbocation. Second, carbanium ion nomenclature. In the carbanium ion nomenclature, the term carbanium ion is used for the most commonly carbocation or the classical carbocations with covalency of 3. Example, CH3 positive. The term carbocation is used for the both carbonium and carbanium ion. Okay, moving further forward, let's discuss about the structure of the carbonium ion. As you are listening, the carbon atom in the carbonium ion is sp2 hybridized, in which the bond angle is 120 degree. The three sp2 orbitals form 3 sigma bond with the 3 substituents, or the remaining p orbital is empty. The species is trigonal planar in the shape. The shape of carbonium is the trigonal planar. It contains 6 electrons in the valence shell around the central atom. And let's talk about the formation of carbanium ion. Clear? The reaction in which the carbocation are formed by a heterolytic cleavage of the covalent bond, in the which the leaving group takes away both the bonding electrons of the covalent bond, are given below. Ionization of alkyl halides in polar solvent, like for example taking the example of tert butyl chloride. आयनाइजेशन करवाएंगे तो टर्ट ब्यूटाइल कार्बोकटाइन मिलेगा हमारे पास एल्काइल हलाइड के तौर पर. और एग्जाम्पल लेके बात करते हैं अलाइल क्लोराइड का, CH2 डबल बॉन्ड CH सिंगल बॉन्ड CH सिंगल बॉन्ड Cl का आयनाइजेशन करवाएंगे तो हमारे पास अलाइल कार्बोकटाइन मिलेगा हमको. सेकेंड, हम कार्बोनियम आयन की फॉर्मेशन कैसे कर सकते हैं? बाय द protonation of unsaturated compounds such as alkenes, carbonyl compounds, nitriles. Okay, or third, by promoting of alcohol followed by the dehydration, and fourth, by the determination of primary aliphatic amines with the nitrous acid, and by the action of superacid on alkyl fluorides, and last but not least, the protonation of ethers. Okay, classification of carbocations. First way of classification, the alkyl carbocations are further classified in primary, secondary and tertiary according to the carbon carrying and the positive charge is attached to or 3 alkyl group respectively. Talking about the primary carbocation, the carbonium ion in which the carbon atom containing positive charge is linked either with one or no carbon atom are called the primary carbocations. Secondary carbocations, the carbonium ion in which the carbon atom containing the positive charge is linked with the two carbon atom are called the secondary carbocation. Talking about the tertiary carbocations, carbonium ion in which the carbon atom containing positive charge is linked with three carbon atom are called the tertiary carbocations. Second way of classification, classical carbocations है. Carbocations in which the positive charge carbon atom have the covalency of 3 and in which the positive charge is delocalized by the double or triple bond which are allylic in the position as given in the example of allyl cations. सेकेंडली नॉन क्लासिकल कार्बोकटाइंस हमारे पास जो कि कार्बोकटाइंस है इन विच द यूजली जो ट्राई कोवेलेंसी है पॉजिटिव कार्बन की वो इज एक्सीडेड and in which the positive charge is delocalized by the double or triple bond which are not in a allylic position. This is the point to be noted, that the delocalized of double or triple bond which are not in a allylic position or by a single example हमारे पास मिथानोनियम आयन CH5 पॉजिटिव. फॉर एग्जांपल ले लो एक नॉर्बोनाइल कटायन ब्रिज्ड कार्बोकटायन दैट वी हैव डिस्कस्ड इन अनदर वे. और थर्ड वे होगी इसकी ट्रांसिएंट और शॉर्ट लिव्ड और कार्बोनियम आयन. दिस कार्बोनियम आयन लैक्स एक्सटेंसिव रेजोनेंस stabilized are the known on the transistor intermediates in a certain organic reaction. These are very reactive and the combine readily with any molecules then can give the pair of electrons. Example हो गया first, second, third degree carbonium. Talking about its relative stability, third degree is the most stable than the second degree and the second degree is the more stable than the first degree. Second, talking about the stable carbonium ion, these carbonium ions are so stable that they can be isolated and studied. The stability of these the carbonium ion is explained in the term of the resonance, that is the positive charge or ion is actually not localized on one carbon atom but rather it is distributed uniformly throughout the several possible position carbon. Example ले लेते हैं हम ट्रायल कार्बोनियम आयन, बेंजाइल कटायन, अलाइल cations. Okay, further talking about the stability of carbocations. This is very important to understand the stability of carbocations. So shifting arrangement in the carbocations, the first second shifts or 1 second arrangements in carbocations are very common. Okay, further moving the topic of the free radical. This is very important topic in this unit, free radical. Okay, let's talk about the free radical. The neutral trivalent short-lived, that is low half-life, odd and unpaired electron paramagnetic reactive species which are formed during the reaction by the homolytic fission are called the free radical. Structure of free radical. Free radical can be either planar or pyramidal depending upon the hybridization of central carbon atom. Okay, the planar structure. In the planar structure, the carbon atom carrying odd electrons in sp2 hybridized, having 3 bonds pair at the angle of 120 degree. Thus the unpaired odd electron is in the unhybridized p orbital. The available evidences from the spectroscopic studies suggested that in the most of the cases free radical have the planar structure. Second, pyramidal structure. In this structure, the carbon atom is assumed to be sp3 hybridized. 3 bond pair are the present at the single slightly less than the angle of 1095 degree, and the one sp3 hybridized orbital containing the odd electron. The pyramidal structure can show rapid inversion. And the free radical in which the carbon atom is connected to atom of a highly electronegative preferred to be in the pyramidal shape. For example, CF3 is a pyramidal shape which prefer the most high electronegativity. Okay, further talking about the formation of free radicals. The reaction in which free radicals are formed by the homolytic cleavage of covalent bond either by the heat or light, in which the leaving group take away their own bonding electron, or the covalent bond are given below. First of all, the disproportion of tetramethyl lead by heating. CH3,4Pb टेट्रामिथाइल लेड को हीट करेंगे, हमारे पास लेड मिलेगा और मिथाइल का फ्री रेडिकल हमारे पास होगा. अगर हम इसकी डिस्प्रपोर्शन के बारे में बात करते हैं तो हमें फ्री रेडिकल मिलेगा यहाँ पर. सेकेंडली, हम इसका होमोलिसिस ऑफ पेरोक्साइड बाय द इफेक्ट ऑफ हीट और लाइट, होमोलिसिस पेरोक्साइड को होमोलिसिस करके देखते हैं, हमारे पास इसका फ्री रेडिकल होगा. जैसे बेंजोइल पेरोक्साइड की बात करते हैं, उसको हीट करते हैं तो हमारे पास फिनाइल के फ्री रेडिकल्स आ जाते हैं. लाइक द बेंजोल peroxide, whenever heated, it gives the phenyl free radicals plus 2CO2 plus 2CO2. Moving forward, talking about the heating of ketones, this is very important formation of free radical. Like the कोई भी कीटोन ले लेंगे, RC डबल बॉन्ड OR, उसको HV प्रेजेंस ऑफ लाइट में करेंगे तो एसाइल फ्री रेडिकल मिलेगा हमारे पास, एल्काइल फ्री रेडिकल होगा. और लास्ट की बात करें तो लॉस ऑफ इलेक्ट्रॉन बाय द कार्बोक्सिलेट आयंस एट द नोड्स. ओके, सो क्लियर formation of free radicals. Let's talk about the classification of free radical, how they are classified into primary, secondary, tertiary. Let's talk about it. First of all, the free radical are classified, as you all know, that in the primary and the secondary and tertiary according as the carbon atom carrying the unpaired electron is attached to one. So 2 or 3 carbon atoms respectively. Some of the example of this type of free radical are given below. Like the methyl free radical फर्स्ट डिग्री है, इथाइल का फ्री रेडिकल लेते हैं वो भी फर्स्ट डिग्री का है. अच्छा, आइसोप्रोपाइल फ्री रेडिकल लेते हैं वो सेकंड डिग्री का होगा, CH3C CH3H, वो CH3C CH3 CH3 वो टर्ट ब्यूटाइल है, वो फ्री रेडिकल ऑफ टर्सरी कार्बन का होगा. ओके, तो out of the free radicals shown above, methyl and methyl are the primary free radicals, isopropyl is a secondary free radical, and tert butyl is the tertiary free radical. Okay, after that we will talk about the primary free radical, secondary free radical, tertiary free radical in detail. Let's see. The free radical in which the carbon atom containing odd electron is linking either with one or more carbon atom are called the primary free radical. Talking about the secondary free radicals, the free radicals in which the carbon atom containing odd electron is linked with the 2 carbon atoms are called secondary free radical. टर्सरी फ्री रेडिकल के बारे में बात करते हैं तो लेट्स द फ्री रेडिकल इन विच द कार्बन एटम कंटेनिंग 2 इलेक्ट्रॉन इज लिंक्ड विद द 3 कार्बन एटम, वो होता है टर्सरी फ्री रेडिकल. आई होप यू आर अंडरस्टैंडिंग, you are getting it. We will talk about the shifting of the carbocations, shifting arrangement in the carbocations. Let's see what are the shifting in the carbocations. The first second shifts or the first second rearrangement in the carbocations are very common. The first second shift take place due to the formation of more stable carbocations, since the energy difference in the solution between the tertiary and secondary and the between a secondary and the primary carbocation are about 11 to 15 kilo Pascal mole inverse is also the shifting arrangements are the exothermic. This is important to know that they are the exothermic. These arrangements either involve the first second hybrid shift or a first second methyl shift. एग्जाम्पल ले लेते हैं फर्स्ट सेकंड हाइड्राइड शिफ्ट का. तो एन प्रोपाइल कार्बोकटाइन है, लेस स्टेबल है, तो उसका फर्स्ट सेकंड हाइड्राइड शिफ्ट करके देखें तो हमारे पास आइसोप्रोपाइल कार्बोकटाइन में है जो कि मोर स्टेबल मिलेगा, वो भी सेकेंडरी कार्बन कटाइन में. ओके, एग्जाम्पल वी विल टॉकिंग अबाउट द एग्जाम्पल ऑफ फर्स्ट सेकंड मिथाइल शिफ्ट का ले लेंगे एग्जाम्पल. ओके, let's talk about the cause of occurrence of the rearrangement in the carbocations and the absence of the rearrangement in a free radical. Okay, causes of occurrence of rearrangement in carbocations and absence of rearrangement in the free radical. In the both carbocations and free radical, the central atom is sp2 hybridized. In carbocations, the unhybrid p orbital is empty, but in free radical it has one electron. During the rearrangement of the carbocations, the 2 electron of the migrating sigma bond can easily move into the empty unhybridized p orbital by the following Pauli exclusive principle, that an orbital can accommodate a maximum of 2 electrons. As a result, less stable carbocations can easily rearrange to more stable carbocations. Yes, but in the free radical, the 2 electrons of the migrating sigma bond cannot move into p orbitals, already have 1 electrons, because it's violate the Pauli exclusion principle. Thus the third electron moves in the antibonding molecules orbital, which make the rearrangements energetically unstable and unfavorable. So we can say the carbocations rearrangement occur because they are the energetically favorable, while the free radical arrangement do not occur since they are the energetically unfavorable. After stability of free radical is important, yes, carbon ions formation. We have discussed about the free radical further and the structure of free radicals and the types. There are 2 types of planar structure हो गया और pyramidal structure, उसकी formation पर हमने बात कर ली और उसकी classification देख ली. जो प्राइमरी फ्री रेडिकल होते हैं वो की containing odd carbon electrons, but they are either linking with no carbon and the no atoms. सेकेंडरी की बात कर ली और टर्सरी की बात कर ली. एट लास्ट द फ्री रेडिकल्स इन विच द कार्बन एटम कंटेनिंग द 2 इलेक्ट्रॉन लिंक्ड विद द 2 कार्बन, वो सेकेंडरी हो जाता है हमारे पास। और टर्सरी में बात करें जो फ्री रेडिकल है, जो जिसमें ओड कार्बन एटम कंटेनिंग है वो 3 कार्बन एटम से लिंक होती है, उसको टर्सरी हम फ्री रेडिकल बोलेंगे। थैंक यू। आई होप यू आर गेटिंग इट ऑल दैट आई हैव रीड अबाउट द mechanism reaction. Hope you are getting it, the mechanism of organic reaction. Thank you so much.